Aloha everybody, this is Gigi from Kauai Community College. This is part 2 of graphing by transformation, and in part 2 we are going to be stretching and compressing vertically. Okay, so we're going to change the vertical component by stretching and compressing it. All right, how does that work? Let's see. We are going to use the x-square parent graph. So, and we want to see what happened if we have the function g of x is equal to 2 times x squared. 2 times x squared. Okay, I went ahead and grabbed decimals. And here is the graph of 2x squared. So if we observe what happened, we can see now that the values for the y value for the y is going to be twice as much as the value of the y value of the original of the parent graph. But the x value, however, stays the same. Right? So why is that? Right? So let's think about this for a second. Normally, we would go over 1, up 1, over 1, up 1. Right? Here, we go over 1, but up 2. Normal, we go over 2, up 4, because 2 squared is 4. Here, we are going over 2, but we're going up 8. Why is that? Because we have 2 times x squared, meaning order of operations, we're going to square first, and then we times it by 2. In other words, you have g of x is equal to 2 times f of x. And f of x is the output is the y value. So we have a vertical stretch. So basically, we take the function here, the x squared, and we vertically stretch it by changing the y value. And we multiply the y value by 2. So we vertically stretch this function by a factor of 2. Okay, now if we know that multiplying by 2 is going to vertically stretch, then logically we would say multiplying x squared by 1/2 would vertically compress. That's the opposite of stretch, right? Compress. How does that work? Again, normal was over 1, up 1. Here we have over 1, up 1/2. The y value is half of what it is previously. Okay, and then normal is over 2, up 2. Here we go over 2 as normal, but we only go up, normal we go over 2, up 4. Here we go over 2, but only go up 2. Why? Because it's 1/2 of x squared. And again, if we think about that, x squared is f of x. So g of x is 1/2 of f of x. F of x is the output, the y value. So the 1/2 is being multiplied by the y value, meaning we have a function that is vertically compressed by a factor of 1/2. All right? Now, what happens if we multiply by a -1 in this case, right, to the function x squared? Well, we know that multiplying on the outside does what to the function? It will change the y value, the output. So how does it change? Well, it's going to turn it upside down, right? Or we say this is going to be a flip because g of x is negative f of x, meaning instead of going up, we now go down. Instead of over 1, up 1, we go over 1, down 1, over 2, down 4. All right, and that is how vertical stretch, compressed, and flip work, meaning we are multiplying the y value by a number. Let's kind of put this together here. Your function, your new function, g of x is negative 2 times x minus 1 square plus 5, right? So previously, we know inside is going to shift the x value, and inside we do the opposite, so we shift that to the right one. Outside, with addition, we do it as is, so that means we are going to shift that up 5, and then we're going to flip over because of that negative right there, and then the 2 will vertically stretch by 2. Okay, let's see how this works. I'm going to put a graph up. Now, shifting it right 1 up 5 mean your new vertex is going to be at 1, 5. There's your new vertex right there, 1, 5. Okay, and we're going to flip over. So that means instead of going right 1, up 1, I am not going to go up, I am going to go down. Okay, and I'm going to vertically stretch also. So instead of over right 1, up 1, I'm going to go right 1, but down 2. So here's my new point, and we know that x squared has symmetry, so the other point is on the other side, left 1, down 2. Okay. Similarly, the parent graph said go right 2, up 4. I am not going up, I am going down because I'm flipping this over. But down how much? I am going to go down twice as much. So normal is 4. I am going to be going down twice as much. So that would be down to 8. And here is my 4th point. My 5th point is left 2, down 8, just right on the other side. And then so we have the oh no, what happened? Now we have the graph that look like this. And we can see that the parabola got flipped over, vertically stretched by 2, and then moving right 1, up 5, so the new vertex is at 1, 5. All right, and that is how that works. In the next video series, we will go ahead and look at this stretching and compressing, but horizontally.